Okay, this is my last video on strategies for solving word problems, in which we're going to look at a geometric approach to a problem, as well as how we rewrite formulas for a single variable, or solve a formula for a single variable in that formula. So when we look at example number 6 here, let's go ahead and start by reading it. It says the length of a rectangular basketball court is 44 feet more than the width. So we have 44 feet more than the width is kind of an important thing here, and that's describing its length, okay? Also this, it says if the perimeter of the basketball court is 288 feet, so we have 288 feet given to us, it says what are its dimensions here? So I think that actually it wouldn't be a bad idea to start by kind of conceiving this situation by drawing a picture here. But what we have is our length and our width. And what we usually do is we start by defining a variable in terms of x. So that's what I want to do here. We're going to say, well, what do we want let x equal? So we say let x equal. Usually it's the thing that you're looking for, but the question we're trying to answer here, looking at the last sentence, is what are its dimensions? So let's pick one of the dimensions here. So let's say I say let x equal the length of the court. Then what we're going to do is we're going to say, well, then the length is equal to x. Its width, we need to write the width in terms of its length. So what we're told here is the length of a rectangular basketball court is 44 feet more than the width, okay? So the width would be 44 feet less than the length. And we could look at it as x minus 44. Now we could have switched this around. As a matter of fact, we could have said that x is the width, and then say x is the width, and the length is x plus 44, but we need to come up with this relationship between our length and our width here. But now that we have these two quantities, and actually we can go place them in here, I'll draw on our picture here. So we have the length, we say, is x, and then this would be x minus 44. The width is 44 feet less than the length if the length is 44 feet more than the width. But this is what we have right here. Now what we're told is this: the perimeter of the basketball court is 288 feet. Okay, so we have the perimeter, we're given this information, is 288 feet. So if we wanted to come up with an expression for the perimeter, looking over at our chart here, I've given a lot of geometric formulas. As far as a rectangle is concerned, we say that its perimeter is defined by the expression 2 of the length plus 2 of the width. It makes sense that you take 2 lengths plus 2 widths here. But I'm going to write that out. As a matter of fact, we say that the perimeter is equal, we'll put this back here a little bit, text, perimeter is equal to 2 times the length plus 2 times the width. This is very true. So when we write this expression now, we could say, well, let's let the perimeter equal, and we'll write an equation in terms of x. So we have 2 times the length, which our length here is just x. And we say plus now 2 times the width, and the width is x minus 44. It is 44 feet less than the length, okay? So now that this is all in terms of x, what we're going to do is look at what it is that we're trying to find here. And what we're trying to find is if the perimeter is 288 feet, okay, then what are the individual dimensions, which we're going to solve for x first, which represents our length. So we say the perimeter here in this case, we'll go ahead and plug in 288 for the perimeter. And on the right side here, we can simplify a little bit. We get 2x. After distributing here, we get another 2x's minus 88. And so I'll combine my like terms here. We get 288 is equal to 4x's minus 88. I'm going to go ahead and add 88 to both sides of this. So adding 88 to both sides of this, we get 288 plus another 88. So 288 plus 88. We have 376 is equal to 4x. So now lastly, we'll divide both sides by 4 here, and we should have the length dimension of this chord. So we say 376. If we take that and divide it by 4, is 94. And we should label this, so we said feet. So we say 94 feet is the length of this chord. Now, since we found the length, we say is 94 feet. We still need to solve for the width of this, and we say, well, that would be 94 minus 44. And if we take that off there, we get 50 feet. So just to check this in the context of the problem, not in the equation that we came up with here, but if I were to say now the perimeter is 288 feet, and the length is 44 feet more than the width, I can see that this 94 is clearly 44 more than our width here. And also, if I were to take 2 times our length there, which would be 2 times our 94, so we have 94 times 2. I'll add this to our memory here. So we say memory clear, memory plus. Put that in the memory of the calculator. And then 2 times 50, I guess I don't even need to do that. If I add 2 times 50, I'm really adding 100. And so, whoops. So we have 94 times 2 plus 50 times 2, which is 100. We get our 288, which was the perimeter of the core. So as a kind of a last part of this problem, what I want to look at is, given certain formulas, say like perimeter is 2L plus 2W, how can we solve for just one of these individual variables here? So in this particular instance, we do have the perimeter of a rectangle is 2 times the length plus 2 times the width. We're going to solve this just the same way we solve regular equations, by getting equivalent transformations of this equation. So we say, well, if I want to solve for W, the first thing we usually do is undo addition and subtraction. So we'd say it's appropriate to subtract this loose term over here from both sides. And what we end up with is this. We say P minus 2 times L is equal to 2 times W. And now dividing both sides by 2, we end up with an expression here that would tell us the width. We'll write it this way. The width in terms of the perimeter and the length of that given rectangle in this particular case. But that's what we would do. Now looking at this example over here where it says solve the formula for C, you'll notice that we have 2 terms that have a C in them. So the typical way that we do this here, we say circumference MC, is this. Since both of these terms have a C and we need to get C by itself, what we're going to do is we're going to factor out that common C. So we say C is in common. What we're left with here is 1 plus M. So in this particular case, now I have C times some number here, 1 plus M. If I want to isolate the C, what we'll do is we'll divide both sides times 1 plus M. So we say dividing both sides by 1 plus M, then we have C is equal to P over 1 plus M. So that is the way we'll deal with it if we have more than one term having that variable, but we need to isolate that variable.